Hi everyone, today I'm going to present my case study 1 for assignment 1, the long run relationship between consumption and income. The first step, we have to visualize time series of consumption and income's chain and potential co-integration. We can see this picture, the parallel upward trends in consumption and income suggest the possibility of a long-term relationship between the two variables. So we can assume that these two variables have both long-run relationship and maybe short-term deviations. So we have to do the for the further analyze, we go to the sec 2 to conduct unit rule tests to determine the order of integration of the variables. This table presents the results of the ADF test for the first different series of consumption with a constant and linear trend included. The tax statistics is 12.7274, which is significantly lower than the critical values at the first percentage level. The p-value is 0, allowing us to strongly reject the null hypothesis of a unit rule. This confirms that the series becomes stationary after firstly difference, the same as the income variables, and the t statistics present minus 13.26792, and the p-values is 0, lower than the critical values at the first percentage significant level. So it also allowing us to strongly reject the null hypothesis of a unit rule. This confirms that this income series becomes stationary after first difference. The next step is Johansson co-integration test to determine the number of co-integration relationships. To figure out how many co-integration between these two variables, we have to do the Johansson test. The first step of Johansson test is to find out the leg orders. I use VAR leg order selection criteria for these studies. And we can see this picture here. The final choice of leg 4 as the leg order of Johansson's co-integration test is based on the results of the information criteria, including LR test, FEP criteria, the ACM, the HQ, and all suggest that leg 4 is optimal leg order, with the LR test showing that leg 4 is significantly better than lower leg orders at 5 percentage level of significance. So we have to choose the leg 4 maybe, but to simplify the equation, HQ criteria also suggest that leg 3 SC suggests that leg 3 is better. So to simplify the equation, we choose leg 3 as our leg choice for the next step. The second step of Johansson co-integration is to do the integration rank test. When assuming the number of co-integration vectors is 0, the trace static is 23.29791, which is greater than the critical value of 20.26184. The corresponding p-value is 0.0185, which is less than the 0.05 significance level. Therefore, the null hypothesis is rejected, indicating that at least one co-integrating relationship exists. When we assuming at most one co-integration vector, the trace static is 2.310031, which is less than the critical value of 9.165 9.164546. the corresponding p-value is 0.7155, which is greater than 0.05. So the null hypothesis is not rejected, suggesting there is no more than one cointegration relationship. After we confirm that there are at least one co-integrating relationship between these two variables, we employ fMOLS model to figure out the long-term relationship between these two variables. And we can see from the picture the result of the fMOLS is showed on the left. From the fMOLS results, the estimate long-run relationship can be expressed as follows. The coefficient of income is highly significant, indicating that 1 unit increase in income is associated with an approximately 0.936 unit increase in consumption in the long run. And the constant term is also significant. And the high R square value shows that the model is explain a substantial portion of the variation in consumption, confirming a strong long-term relationship between the two variables. And the next is the guide exercise 1 for assignment 1. I choose the first guide exercise, co-integration and ECM for exchange rates. Also, we can see at this part, the picture shows the daily exchange rate of EUR USD and GBP USD from January 1, 2010 to December 31, 2020. Both exchange rates appear share similar trends, particularly in their peaks and troughs, suggesting a potential long-term relationship. Over time, the rates demonstrate core movement with no present divergence. This visual analysis indicates that these exchange rates could exhibit co-integration, which we will text formally. And we do the unit root text of ADF to both variables. The ADF text results of EUR USD and GBP USD exchange rates indicate that both theories exhibit non-stationary at their levels. But after applying the first difference to the series, the ADF text results shows that both EUR USD and GBP USD become stationary. So both EUR USD and GBP USD are integrate of the order 1, meaning they are non-stationary at levels but become stationary after the first differences. And the next step, we employ angle-Granger two-step co-integration text between GBP USD and EUR USD. This part aims to determine whether a long-term relationship exists between the two exchange rates. Firstly, we need to estimate the long-term relationship using least square and their text the stationary of the residues to confirm co-integration. The picture on the left shows the long-run relationship between GBP USD and EUR USD was estimated using OLS. The equation is shown below. The R square value 0.6 indicates that EUR USD explains a substantial portion of the variation in GBP/USD. Both the intercept and the coefficient of EU/USD are statistically significant, demonstrating a strong and consistent linear relationship between the two currencies over the study period. Secondly, the residuals from the long-run regression were examined obsessionally using the ADF unit rule test. From the picture, the tax statistics from the residue is minus 2.0880, which a p-value of 0.0354. This result is significant at the 5 percentage level, indicating that the residuals are stationary under the assumption of non-deterministic terms. After that, we can use the ECM model. The picture shows the results of ECM. ECM equation is shown below. The error correction term ECT with a coefficient of minus negative 0.00534 is negative and significant, confirming that approximately 0.34 percentage of the deviations from the long run equilibrium are corrected in each period. And the last but not least, we're going to the results and discuss the implication of the foreign exchange market. The co-integration between GBP/USD and EUR/USD indicates a stable long-term relationship reflecting shared economic fundamentals. In the short run, change in EUR/USD have significant and positive impact on GBP/USD, as shown by the short-term coefficient of 0.6856. However, the adjustment to deviations from the long-run equilibrium is low, with only 0.34 percentage of this equilibrium corrected in each period. This highlights a persistent short-term misalignment between the two exchange rates before they converge back to their long-term relationship. Policymakers and market participants can notice this relationship to forecast one exchange rate based on movements in the others, enhancing hedging strategies and optimizing portfolio management. That's all. Thank you very much.